All right, our last type of elevator is going to be an elevator going downward. And again, we'll draw this. Oh, gosh. We'll draw the elevator and then we'll pretend it's a rectangle. And then our tension of the rope is that way. We have mg, and this is mass of both the elevator and the person together. So that's going to be 500. In this one, we have an acceleration of 3.2 meters per second squared. All right, so let's see what this looks like. The sum of my forces in the y direction is going to equal negative ma, okay? Because my acceleration is going downward, that negative sign is going to show that downward motion. And then sum of the forces in the y direction is going to be my tension, which is this up here, minus mg. And so I can put these two things equal to each other. So T minus mg equals negative ma. And then let me scooch in here. I take the negative mg, add it to both sides. So I end up with T equals mg minus ma. And again, this next step is unnecessary. I'm just doing it because it is less calculator strokes for me. Okay. So to find my tension, I'm going to take my total mass, which is 500 kilograms, my gravity, which is 10 meters per second squared, and I'm going to subtract from that 3.2. So that should be minus 3.2 meters per second squared. That should give me 6.8, I believe. So 10 minus 3.2 gives me 6.8. And if I take that 6.8 and multiply it by 500, I get a tension of 3,400 newtons. Now this is the same elevator, it's just accelerating downward instead of upward. So my imbalance of forces is actually in the direction of my gravitational pull, or the weight of the object. Okay, let's go ahead and take a look at the person that's inside the scale. So sum of my forces in the y direction is going to equal negative ma, and that's going to be my normal force of the person minus mg of the person. So this is all the person, whereas this was person plus elevator. Okay, that's why we used this 500, because it's the person and the elevator. Well, I could say that normal minus mg is equal to negative ma. Again, I can use this strategy going from here to here so that my normal force is going to be equal to mass times g minus a. So that would be 50 kilograms times 10 meters per second squared minus 3.2 meters per second squared. Now notice that my 50 kilograms is just 10% of that 500. So I would anticipate 340 newtons. Let me just put in the calculator to verify. So 50 times 6.8, yep, 340 newtons. So 340 newtons and 400 newtons. Just an FYI, on the quiz, I'm likely not going to be giving you like a person that has the same mass or 10% of the mass of the person and the elevator, so that you actually have to, calculate it. This is just happens to be how the numbers worked out on this one. Okay.